Hi, welcome back. This is Professor Ridge, and today's lesson, Unit 5C, Statistical Tables and Graphs. So we'll start out with some definitions. So first, for frequency tables, a basic frequency table has two columns. Okay, the first column lists all the categories of the data. And the second column lists the frequency of each category, which is the number of data values in the category. Okay, so frequency, how often does it occur? So again, that's going to list the number of data values in the category. Okay, and then we have what's called relative frequency. The relative frequency of any category is the fraction or percentage of the data values that fall in that category. So the formula, relative frequency, so you're going to take the frequency of the category and then divide that number by the total frequency for all the categories. Okay, and that just give you that fraction, or you can turn it into a percent. That should be a Q. Okay, and then we have the cumulative frequency of any category is the number of data values in that category and all the preceding categories. This is kind of like a running total. All right, so data types and binning. Qualitative data consists of values that can be placed into non-numerical categories. Okay, so we have two types. We have qualitative and quantitative. So qualitative, I kind of always think of quality, right? So it describes a quality, that's not a numerical. Okay, non-numerical. So that's the key. Okay, and then the quantitative data represents counts or measurements. So these counts, if it's occurrences, right, that would be a frequency or measurements. So quantitative data is stuff that you can measure or count. Okay, so when dealing with quantitative data categories, it's useful to group or bin the data into categories that cover a range of possible values. Okay, so a range of possible values. All right, let's look at an example of the data types. Classify each of the following types of data as either qualitative or quantitative. All right, so our first example is brand names of shoes in a consumer survey. So if you stop and think about it, okay, think of some brand names of shoes. You got Adidas, New Balance, Nike, right? So just name, so those aren't something that you can remember. Quantitative is you can measure it or count it. And then qualitative is non-numerical. So that's this one. So this is non-numerical, so this would be qualitative. All right, next one is heights of students. So if you think about heights, right, we'd give answers like, oh, I'm 5'2", or 5'8", or 5'7", 6'3", what, right? So those are measurements. Heights are measurements, which definitely would be quantitative. All right, so this one can be confusing for most people. So audience ratings of a film on a scale 1 to 5, where 5 means excellent. So the the thing that throws people off is because we're assigning numbers to a quality, right? That we think, hey, that's a great film. So instead of saying, hey, it's excellent or good or very good or bad or really bad, right? We're assigning numbers to those. So you might be tempted to say it's quantitative, but this is actually qualitative. Okay, so again, it's qualitative. So I just typed out this just to remind you, right? So it's subjective opinions about the film, not counts or measurements, right? And again, we're describing, what we think it's good, bad, excellent, whatever. Okay, so that's a qualitative. All right, let's look at this example, summarizing raw data. So consider the following 20 scores from a 100-point exam. Okay, so we got all these scores. Determine appropriate bins and make a frequency table including columns for relative and cumulative frequency. So let's look for the lowest and highest score. So let's see, lowest 75, 72. All right, and then the highest is going to be 98. Looks like. So let's do 5 points for our score here. So let's say 95 to 99, 90 to 94. Let's see. So we're going to go to 89. And look, we don't want any ambiguity. So I didn't put 90 to 95. So does 95 go in which column, right? So you want to make sure they're distinct. There's no decimal points. So this would be 85. And then 80, 75, 70. Our total. Okay, so let's see. 76 will go in this one. I'm just going to make some tally marks. 80, 78, 78, 76, 94, 75, 98, 77, 84, 88, 81, 72, 91, 72, 74, 86, 79, 88, 72, and 75. So it looks like we have 1, 2, 3, 7, 4, and that should add up to 20. So just make sure, just see they total is 20. So 6, 9, 16, 20. Yep. And the relative frequency, remember you're going to do 1 divided by 20. So that's 0.05, which is 5%. Okay. 2 out of 20, that's 0.10, which is 10%. 3 out of 20 is 0.15. You just type it in your calculator. But every one is 5%, so right? 5, 10, 15%. So that's 15%. So relative frequency, remember it's the number of occurrences divided by the, the frequency for that category divided by the total frequency, which is 20. So 7 out of 20 is 30.35 or 35%. And 4 out of 20 is 20%. And of course, 20 out of 20 would be 1, which is 100%, of course. All right, now cumulative, right, is, so for the first category is 1. For the second category, you take the 1 plus the 2 from this frequency, and then 3 plus 3 would be 6. 3 plus 6 would be 9. 7 plus 9 would be 16. 16 plus 4 would be 20. Okay, and you won't do 20 and 20 again, right? Because that's just the total category. Okay, bar and pie graphs. A bar chart shows each category with a bar whose length corresponds to its frequency or relative frequency. And pie charts, and notice it says graphs up here, charts. You can interchange pie charts, pie graphs, same thing. Okay, so a pie charts are used primarily for relative frequency because the total pie must always represent total relative frequency of 100%. So basically the whole pie would be 100%, and the size of each wedge is proportional to the relative frequency of the category. So if I had, so that would, you don't have to copy this, but that would represent the pie 100%, and if I were to cut it in half, right, this would be 50%, and that would be 50%. If I cut that piece in half, it'd be 25%. Cut that in half, that'd be 12.5%. 12.5%. Okay, and you can see, and that would all add up to 100%. So that's basically how you go about making pie charts. So you'd have to do proportional, the size that represents the percentage. Okay. Okay, so the bar chart and pie chart below both show the data from 5.1, just to show you the difference between the pie chart and a bar chart. Or again, you can say pie graph and bar graph. Okay, so here's the frequency table for grades: 4 A's, 7 B's, 9 C's, 3 D's, 2 F's, so that's 25. If we do it as a frequency table, so on the left side here, this is the actual frequency, right? So we got 4 A's, 7 B's, 9 C's, 3 D's, and 2 F's. And on this side, it's written as the relative frequency as percentages. Now this is the percentages, so if we were to make another table like we did here, the relative frequency, we'd take the frequency divided by the total to get those percentages that's written here. And then you can take those percentages and make them in a pie chart, right? So A's, there was 4 out of 25, which is roughly 16%. Is that exactly? Hang on, let me check something. No, so it's not roughly, it's exactly 16%. So 4 divided by 25 is 16%. Okay, so And then you can see F's was 2 out of 25, which is 8%. And then D's was 3 out of 25, which is 12%. And C's was 9 out of 25, which is 36%. And B's 7 out of 25, which is 28%. And you can see the biggest piece of the pie here is the C's with the 36%. Okay, so it gives you a nice visual representation of those percentages. Okay, so some important labels for graphs. So the title and caption, title or caption. The graph should have a title or caption or both that explains what is being shown and, if applicable, lists the source of data. Okay, so that's really important to label them. Okay, next, vertical scale and title. Numbers along the vertical axis should clearly indicate the scale. The numbers should line up with the tick marks. Include a label that describes the variable. Okay, horizontal scale and title. The category should be clearly indicated along the horizontal axis. Tick marks are not necessary for qualitative data, but should be used with quantitative data. Include a label that describes the variable that the category represents. And finally, a legend. If multiple data sets are displayed on a single graph, include a legend or key to identify the individual data sets. Histograms and line charts. A histogram is a bar graph for quantitative data categories. The bars have a natural order and the bar widths have a specific meaning. A line chart shows the data value for each category as a dot, and the dots are connected with lines. So for each dot, the horizontal position is the center of the bin it represents, and the vertical position is the data value for the bin. Okay, and a time series graph is a line chart or histogram in which the horizontal axis represents time. Okay, so histogram and line chart examples, just to show you the difference here. The histogram and line chart below both show the same data. So notice the title, we got the exam scores. On the left side here, we got frequency, both of them. They're numerical values, right? They're nice scaled equally, so that's important. On the bottom are our scores, 70 to 75, 75 to 80, 80 to 85, 85 to 90, so on. Okay, and so on the bar graph, or the histogram, it's basically a bar graph, but with, remember what we said, is a bar graph with quantitative data categories. The bars have natural order and the bar widths have a specific meaning. So this width is the range from 70 to 75, or 74.9 basically. Okay, so that has frequency of 4, 7, 3, 3, 2, 1. And then if you look over here, right, if you go right at the center, for 70 to 75 was 4, put a dot there, right at the center, that was 7 for that range, right, and then you just connect it with dots, right, and basically that's it. So me personally, I would prefer the histogram version for this, for the category, just because of the categories and the scores. But again, you can kind of compare the difference between the two. All right, example 2, Oscar-winning female actors. The table shows the ages at the time when they won the award of all Academy Award-winning actresses through 2017. Make a histogram and a line chart to display these data discuss the results. Okay. So let me copy the table on the next page. Hang on. All right, so you could use, like in Excel, they have nice features to create histograms and line charts and all that. So you could use that, but we're just going to do one by hand here. Let's see. So we want to title this. So this is ages of Academy Award winning actresses. Okay, so I just converted it to text. And then a number of female actors on the side here. And then on the bottom, this is age at the time of award. All right, so let's see. So between 20 and 29, so look, we're going to go from here to here, 20 and 29. I got a tool for a bar graph. 32 is roughly this high. Okay, and then 34, so that's just below half here. I said I had a tool, I was going to use it, but that's good enough. And then we're going to drop down to 14, which is right about here. And then 2, so roughly this big. Right, because if you go halfway, that's 5. That's like 2.5. So just a little below that. And then 1 and 1. So 1 and 1. Oh, whoops. Messed up. So let's see. 60 to 69 is 6, which would be just a little more than a half there. And then 1 and 1. So 1 and 1. Now to make up, and then of course you can fill it in. I don't know if I have. Okay, I'm just going to leave it like that. And then if we wanted to do the line chart, we see histogram and a line chart. Okay, so basically you go at the middle of each of them. So from 0 to 10, there's 0, 0. And we got 32, 34, 14. And you just do it right in the center there. 2, 6, 1, 1, and then 0. And then connect the line there. So, okay, so simple as that. Now, typically, you're not going to draw these by hand. It's nice to be able to do it one by hand just to see the process. But a lot of software, especially statistical software, they have built-in features that you can just say, okay, make a histogram from this chart, and you just basically click the button, and the chart magically appears. Excel is really good at that. All right, example 3, reading time series diagrams. Okay, the figure shows a time series graph of homicide rates in the United States. Briefly summarize what it shows. Okay, so we can see, let's just kind of read through. Here's the title, U.S. homicide rate. On the side, it's labeled at homicides per 100,000 people. So these are again rates. So this 5 will represent 5 homicides per 100,000 people. Okay. Now on the bottom, you can see years. Looks like each tick mark is 1 year. So if we look at this, in 1960 there was 5 homicides per 100,000 people. Kind of dips down, it goes down. So in 1963, looks like, 4.5, and then it gradually, it's increasing, pretty good increase here, steady increase from 64 to about 74, comes back down, right, just a little bit, kind of peaks again here in 1979, comes back down, and goes up, down, kind of peaks again in 1990, 91. Okay, that's 80. Here's 91. So yeah, that peaks in 91. And then look, it's a nice steady, well, it's a big decrease, right? So the steeper that is, right, the faster the decline rate. And then kind of it's leveling off since about 2000. It's kind of dipping down. Okay. So you can this is a time series graph. You can see the change over time. So it's really, really effective way to show this data as the change of homicide rate throughout from 1960 to 2012. All right, and that brings us to the end of this lesson. Again, go to the Pearson My Lab site and do the homework there, and I will see you next time.